This is a continuation of the problem from set operations in Venn diagrams part 1. So we have all of the different entries or the elements of the universal set into the Venn diagram, and now we're going to use the Venn diagram to evaluate the operations down below. Okay, so the Venn diagram is not necessary for these, but a lot of times it can be helpful, especially as we get more and more elements in our sets and our subsets, because a lot of times it's easier to just look at a region visually, figure out which region satisfies whatever the conditions to the question are, and then to fill in whatever elements are inside that region. So I'll give you an example. For the first one, we are looking at the intersection of P and Q. So the intersection of P and Q is going to be all the elements common to both P and Q. One way we could do this is we could write out the list of all of the elements in P, which would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and then write out all of the elements in Q, which would be 3, 6, 9, 12, 15, 18, and then identify which elements are in both of those, okay? But an easier way to do that is to look at the graph. So if I'm looking at my Venn diagram, okay, I'm looking at the region that is the overlap between P and Q, which I'm going to highlight here. Okay, so this region right here. So if I'm looking at just the regions first, I can identify that, and then I can see that the only elements in all three of those are 6, 12, and 18. Okay, and then that's my answer. So here, looking at the picture is a little bit nicer than making two big lists and then trying to identify what they share. Okay? For R union Q, I'm looking for all of the elements that are in R or Q. And again, I could make a big list of R, a big list of Q, and then I could put them all together and make sure I don't have any duplicates or anything like that. Or I could just look at the graph. And for the graph, let me switch colors here, or the Venn diagram, I should say. I'm looking at the union of R and Q, so that's going to be everything that is inside either the R or the Q bubble, which is all of this, okay? And then I can list them based on that region. So, and because I don't really care about the order, I'm just going to go left to right, kind of down to up here. So 4, 8, 16, 12, 6, 18, 3, 9, and 15. Again, order does not matter, so it's easier for me to look at it that way than try and sort them as I go. Okay, so that's R union Q. For the next one, we have Q prime intersection R. Okay, we want the intersection of Q prime and R. So first of all, let's talk about Q prime. Remember, prime means the complement, so that means everything that is not inside Q. So switching colors again, not in Q is going to be everything here, okay, up to there, not in Q. So all of those values that are kind of surrounded in pink. So we have that, so that's all Q prime, okay? And then we want the intersection between that and R. So now if I'm looking at R, okay, which is this bubble, I see that my intersection occurs only in this little region right here. Okay, so really, I'm looking at just those three numbers, which are 4, 8, and 16. And so here's another example of how looking at the Venn diagram is going to be more efficient than making lists. I would have to do not Q, I would have to list out, let's see, 13 different elements, and then I would have to list the 4 elements from R and then try and figure out where they intersect. And so here it's just easier to use the region and then fill in whatever elements are in that region. For the next one, P minus R. So now I'm taking all the elements that are in P and I'm getting rid of whatever is in R. Okay? So looking at the bubble that's in P, I'm going to try and erase things without screwing too much up here. Just a second. Carefully. Ooh, there we go. That's better. Okay. So P, but not in R. So I'm looking at just this part of P that is not inside R. Okay, and it looks like I've got all of the even numbers except for the ones that are multiples of 4, and so that's going to be the set of 2, 10, 14, 6, and 18. Again, I don't really care about the order of those. Okay, R union P. Okay, R union P. Now for this one, I'm going to think about a comment that I made earlier, and that is this right here, that R is a subset of P. And the reason I care about that is since R is a subset of P, that means that there are no elements in R that are not already contained in P, meaning if I want the union between R and P, that's going to be represented by just the elements that are in P, and I don't need to worry about adding any additional elements. So here, this is equal to P, or I can go ahead and list them, okay, which is all of the even numbers. Okay, in the universal set. All right, and then for this last one, we actually have a couple of operations happening. We have an intersection, we have a union, and we also have a complement to think about. As we go through these, we're going to do kind of follow the same order of operations as we would with arithmetic. In other words, if there's something in parentheses, that needs to be done before something outside the parentheses. So first I'm considering everything that is in not P or Q. Okay, not P or Q. And for this one, I'm going to actually sketch, since I've kind of scrolled down here, I'm going to sketch the regions again and just look at them in terms of regions. Once I have my final region, I'll scroll back up and figure out where that's represented. You know, my answer region is, or my solution set is represented on the original Venn diagram. But right now I'm just going to look at this. Okay, so first of all, not P. Okay, so for not P, should label these P, Q, R, okay? Not P is going to be everything outside the P circle, okay? And I want the intersection of that, let's see, let's do just a different color here. Okay, I want the union of not P and Q. So anything that is not a part of P, okay, or anything that is a part of Q gets added into this first part, okay? That's going to be in green here, so not P, staying outside P, okay? And then here, but now we're adding everything inside Q. Okay, so everything that is shaded is not P or Q, okay? It is... all of the stuff that is striped with green, okay, is the answer or the subset to the first part, okay? So this is the green striped part, okay? Now, what I'm looking for is the intersection between that and R. And again, I'm going to do this with some, not really shading, but some lines here, okay? And I'm looking for the intersection between the green lines that I just drew and R. And R is the bubble at the bottom, so I'm going to go ahead and fill in R, okay? And since I'm looking for the intersection, I'm looking for what regions have both the pink, okay, so the pink, and the green lines. And it turns out that that is just this space right here, okay? Just those two little pieces inside the overlap, okay? So now that I have that region, I'm going to go back to my original Venn diagram and figure out what is represented there. And that region is the same as this region right here, okay? And I can see that there's only one element in that little eye-shaped intersection there, and it's a 12. So the answer here, my subset, is just 12. Okay, so again, the Venn diagrams may not be always necessary, but a lot of times, especially as you have more and more elements and more groups interacting, then having a visual representation can make answering these questions a little bit easier because you can do it just based on the regions and then go back and fill in whatever values appear inside those regions.